In this video, we look at polynomial division. First up, dividing a polynomial by a linear factor, so something like ax plus b. Remember, when you divide by any term, then the remainder is always less than the divisor. So if I divide by a linear factor, what's less than a linear factor? It'll be a constant. So my remainder will be a constant if there is one. All right, so if p of x is divided by ax plus b, there's going to be some quotient. So some polynomial, call it q of x. The remainder we express over the divisor of ax plus b. If you've got this expression here, you can simplify that to make p of x the subject. So multiply everything by ax plus b, and we end up with q of x times ax plus b. And here the ax plus b would cancel out, and you're left with r down here. So, this example, dividing by x plus 3 using long division. So, x plus 3, we put that in front of x power 4, etc., making sure you've got place value. So, my first term is x4, I've got 0 lots of x cubed, 2 lots of x squared, there's 0 lots of x, and there's a constant of minus 1. Now, when I divide using long division, I look at how many terms I'm dividing by. I've got 2 terms here, therefore you start writing your answer 2 terms in. And doing that, you have all your x cubes, x squareds all lined up. So now what I do is work out what do I times the x by to make it become x power 4, and that's x cubed. So I times by x cubed, and x cubed times by x will give me x power 4, x cubed times by the 3 would give me plus 3x cubed. And notice here, all your x cubes are lined up, all your x power 4s are lined up. So now we subtract. I would not encourage you to write the take symbol, because writing the take symbol, students will do the first subtraction, then they'll forget in here we're subtracting as well. So just remember you are taking away, don't write the symbol there. So x power 4, take x power 4, there's no x power 4 term, and 0x cubed, take 3x cubed is negative 3x cubed. Bring down your 2x squared. Now I work out what I times the x by to make it become negative 3x cubed, which is negative 3x squared. And once again, notice my x squareds are all lined up here. Now multiply the negative 3x squared here by this expression here, and I'll get negative 3x cubed and then minus 9x squared. Now subtract these two, and we end up with no x cubes and 11x squared. Bring down the 0x. Work out what I times the x by to make it become the 11x squared. That'll be 11x. So 11x times by x would make 11x squared. We've got 11x times by 3 is plus 33x. And now we subtract those two there. We get no x squareds and minus 33x. Bring down the minus 1. What do I times the x by to make it become negative 33x, or negative 33? So negative 33 times by x plus 3 gives me negative 33x, and then take 99. So now we take away these two here. So subtracting here, we end up with negative 1 plus 99, so we end up with 98. And therefore, if I write x4 plus 2x squared take 1 in this form here, then q of x is the quotient, which is that expression there. So we have x cubed minus 3x squared, 11x take 33. That's multiplied by the divisor of x plus 3. And then we have our remainder. Our remainder is 98. So my polynomial, let's call it p of x, can be expressed in that form there. Let's put brackets around q of x there, all multiplied by the x plus 3. Now I've got the same calculation, but done a little bit differently, just by using the coefficients rather than writing the x's, which is easier, but it doesn't give you the checks of having all your x squareds or your x cubes lined up, so you can't tell, so you've got to be very careful. So if I divide x plus 3, that's 1 and 3 as my coefficients, into x power 4, 0x cubed, 2x squared, 0x, and minus 1 as the constant. Two terms here, start two places in. So times 1 by 1, times by the 1 and the 3 would give me 1, 3. Now subtract, I end up with minus 3 here, bring the 2 down, multiply the 1 here by negative 3 to make negative 3 down here, and also negative 9. Subtract, I'll get 11, bring down the 0, times the 1 by 11, and that will give me 11 and 33. Subtract, I get negative 33, bring down the minus 1, multiply the 1 here by negative 33, and that will give me negative 33 and negative 99. Once again, subtract those there, and you'll get 98, which is my remainder. So I end up with the same values. A little bit more simply, but you don't have those checks, as we did back here, with all of the x cubes, x squareds, etc. lined up. All right, dividing by a quadratic. Once again, as said previously, if you divide by any divisor, then your remainder has to be less than the divisor. So in this case, my remainder is expressed as a linear function. It may turn out that that linear function is in fact just a constant. Right? So it has to be at least linear, if not smaller. So in this one here, if I were to divide this, let's do it just with the coefficients. So I've got the 1, negative 1, and the 1 for the divisor, and that is going into, I've got x power 4, x cubed, no x squareds, minus 1x, and 1. I've got 3 terms here. I start writing my answer 3 places in. So I times by 1 first up. So if I times this expression here by the 1, I end up with 1, negative 1, and 1. Now subtract, and I will get 5, negative 1. Bring down the negative 1. Now I multiply this by 5 to make the 5 down here. So I end up with 5, negative 5, and 5. If I subtract, I'll end up with 4 here, negative 6. Right, bring down the 1. I times this by 4 to make the 4 over here. So I end up with 4, negative 4, and 4. If I subtract now, I end up with negative 2 and negative 3. So therefore, my polynomial, once again, call it p of x. The quotient is my quadratic here, so x squared plus 5x plus 4, multiplied by the divisor, which was that expression there, so x squared, take x plus 1, and the remainder is that expression here, which is negative 2x, take 3. So now we've expressed our polynomial in that form there. That will get you working through 2D1 and 2D2. Have a go.